Hello, this is Mr. Ferris, and this is the ProbStats Finite Math Lesson 8B for an e-learning day. And this is the second lesson on linear regression. We're going to focus on residual plots, interpreting them, and making predictions. You should have this handout already. If not, it is on Canvas. You can download it. And so the very first thing that you'll need to do is type in some data into your calculator. We are going to focus on these two variables: the weight of a certain group of cars and the miles per gallon that they get on the highway. And so we could pick the weight in thousands of pounds, but I think we're just going to go with the raw weight in pounds just to keep it a little simpler. And when we first want to type this in our calculator, we may want to answer the question, which one is the explanatory and which one's the response variable. And I hope that it makes sense that the miles per gallon are going to be doing the responding to the weight. The weight will be the explanatory variable. So therefore, I would suggest, if I were doing this, I would suggest that we put the explanatory variable in the first list and the response variable in the second list, just to keep things kind of ordered like we like to think. So I'll let you type those in your lists. You probably should pause this video before we move on to the next question. The next question, or really the first question, I guess, is would a linear model be appropriate? Now, this is not strong or weak or anything like that. It's just whether we should even be doing a linear model in the first place. So the very first thing that we should be doing is sketching a graph of this, which on our calculators would be a stat plot. Go to stat plot and create a scatter plot for the data. And when you do that, you should see the answer to the question. Is a linear model appropriate? If you get a graph that looks something like this, then you're probably on the right track. And so therefore, because we generally see a linear pattern, generally it looks like it's linear, so I think we can say pretty confidently that yes, since the scatter plot appears to have a linear form, we would be allowed to put a linear model on this data. So I believe that'll be the answer to the first question. Questions 2, 3, and 4 on your worksheet are about the means and standard deviations and correlation. And then also number 4 has you write the least squares line. So you'll have to create a linear regression on your calculator and get the slope and y-intercept. So I'm going to let you do questions 2, 3, and 4 on your own. You can stop, and probably should stop the video right now and get those done just for practice, because we are going to use those later in the video. So go ahead and do that, and then play it again when you're ready to do number 5. All right, I assume that you answered this question with weight. We did say that weight was the logical explanatory variable. Weight tends to explain the efficiency, the miles per gallon of cars. And then when you write the least squares line, there should be an S there, the least squares line. We always want to put a hat over the predicted amount, and we're going to predict the highway miles per gallon. That's the response variable, and that would be kind of like the y in the equation. And according to our calculators, it'll be 54.8 minus 0.0085 times the weight in pounds. That will be our least squares regression line. It's also considered the best line of fit, or just the regression line for short. So hopefully you had that off of your calculator. The next question, number 5, is to interpret the slope in context, and this gets a little tricky, but we have practiced it a few times, so I hope that you could interpret that on your own. And again, it would be good practice for you to pause the video right now before I show you the answer, and just to see how close you can come with your written interpretation of slope. Here's what I would say. The model predicts a decrease of 0.0085 highway miles per gallon for every increase in weight of 1 pound. Now, the only thing about this is it's a little unwieldy, I would say, simply because this is such a teeny tiny number. But technically, that's what it says. You're going to gain just a teeny tiny bit of fuel efficiency for every, you'll lose a teeny tiny bit of fuel efficiency for every pound of weight that you have. Now, alternatively, what you could say here is, instead of saying for 1 pound, you could say for every 1,000 pounds. If you want to ramp that up by a factor of 1,000, then we could also ramp this up by a factor of 1,000. And you could alternatively say that you get a decrease of 8.5 miles per gallon for every 1,000 pounds of weight added to a car. That would be a little more realistic. Those would be a little more easier to understand numbers, 8.5 miles per gallon decrease for every 1,000 pounds. But it's not incorrect at all to say it like we said it. So I guess I'll just leave it like that since we decided to go with pounds. The second answer, the interpretation of y-intercept, go ahead and pause the video and see if you can write out an interpretation for this first. And the way I would probably say it is similar, is the model predicts. And remember, with a least squares line, the y-intercept is where x is 0. So when a car weighs 0 pounds, this is saying that you'd still get almost 55 miles per gallon, which is nonsense, of course, but we know that sometimes y-intercept interpretations are nonsense because it's such a far end of the model that it doesn't really apply to the data that we have. Next question, number 7. Use the least squares regression line to predict the highway miles per gallon for an Accord. If the Accord weighs 3,040 pounds, then use this to make a prediction. So what we do is we plug that number into our equation, and if you do that, you'll get, actually it's going to get plugged in right here. 3,040 is going to go right in there, and you're going to take it times the 0.0085, subtract it from 54.8, and you get 28.9 miles per gallon. So when you're predicting, all you have to do is plug in the x value into the equation, and that gives you the y value or the predicted value. So we would predict that a Honda Accord would get 28.9 miles per gallon. Wonder if it really does. Wonder if this model's accurate at all. Well, it turns out a Honda Accord actually gets 31 miles per gallon. So just as expected, our model's off just a little bit. And so now we can calculate this thing called a residual. A residual, you might recall, has a formula where you take the actual y value and you subtract the predicted y value. So all we have to do is take those two y values. The actual one is 31. The predicted was 28.9. And when you subtract them, you get a final answer of 2.1 miles per gallon. So that would be considered the residual for a Honda Accord. And because it's positive, what that means is that the Accord gets 2.1 miles per gallon higher than we would have predicted using this linear model. So a positive residual is always higher than predicted. A negative residual, when you find it, would be considered less than predicted or lower than you would have predicted with the line. Next question, number 9. Can we use this least squares line to predict the weight of a car? We just used it to predict the miles per gallon from weight, and now we wonder if we could use that same equation to predict weight for a car that gets 22 miles per gallon. In other words, can we use this formula backwards to back solve? And the answer is absolutely not. This equation was a one-way equation. The way we set it up, we picked the explanatory and the response variables purposely. And so this model is only going one way. It's only designed to predict miles per gallon given a weight. It does not work the other way around. We'd have to switch the, we'd have to do a whole new model. We'd have to switch the variables, reverse them on the axes, and then type them in our calculator again and get a different line. But it really wouldn't probably be appropriate anyway, because the relationship really doesn't go that way. You know, it's really true that weight causes or is affecting miles per gallon, not the other way around. The miles per gallon does not affect the weight. And so it's probably not even logical to do it the other way around. Second question about models is, how about could we use this model to predict for some car, or maybe this would be more like an SUV, that weighs 5,200 pounds? Well, that certainly is the right direction. We want to use this line to predict miles per gallon. However, there's another problem with 5200. If you look at the data set, and especially the weights, notice that 5200 is way above all the weights. The highest weight that we had was 4,000 pounds. This is way above that. So no, this would not be appropriate. And the reason is 5,200 pounds is pretty far outside our data. So the least squares line is really just a model for the data that we have. It does not necessarily work for data that's outside the range that we have. So it would not be appropriate to use this model for numbers that are way outside the range of the data that we used. That would be considered dangerous. It's certainly something that is done. I mean, economists are always predicting things in the future, and weathermen and meteorologists are always predicting the future. So it's done in real life, but it is a little dangerous. And as we saw recently, weather especially can be very, very bad predictions. And the official word for this, when you're predicting beyond your data set, it's called extrapolation. That prefix extra kind of means going beyond. And so this is called extrapolation, and it's just an unwise thing to do. Or perhaps if you do it, you should just acknowledge that you're not sure and you're going to do this cautiously. Number 11 is a question about creating a residual plot on your calculator, and I made another video that specifically shows and demonstrates how to use your calculator to create a residual plot. So I'm going to let you watch that to get this skill and to practice that. And then number 12 is a question about causation, and it's asking whether or not we can conclude that the weights are actually causing miles per gallon to be lower. Is causation a reasonable conclusion because we have a strong association? And of course, I hope you remember, even just from the storks and the babies example, that just because there's a strong association, that does not necessarily mean that one variable is causing the other variable. So certainly there's some logic to thinking that a heavier vehicle is not going to be as fuel efficient, and so there may be some causation, but there also could be something, some other lurking variable, like perhaps the way that heavier cars are driven. People that drive SUVs may drive differently than those that drive cars that are more fuel efficient. So there could be some other variables at stake, and there might be some association that is causation, but there also could be some other explanations for why the association is so strong. And finally, we have a graph that shows the average TVs per person in several countries in the world. And then on the y-axis, we have the life expectancy in that same country. And you notice there is a positive and fairly strong association. Now it's curved, of course. But there does seem to be something to be said like this, that countries that have more TVs per person tend to have a life expectancy that's higher. And so the one thing, though, that we've got to be really careful not to conclude, just because there's an association, does not mean that there's causation. It doesn't mean that somehow having lots of TVs in a country is causing people to live longer. It's probably more another thing that I think you could probably figure out, especially if you've taken economics. What could be a lurking variable in this scenario? I'm going to leave that to you to think about. And I think it's probably pretty obvious if you've studied world history and if you've studied economics especially. All right, so finally we get to the homework assignment. You've got 4 homework problems on pages 185 to 188. And you should do those 4 homework problems before you take the quiz over this lesson. And then also, of course, next time you would be expecting to have a test over the entire chapter. So if you have any questions, of course, make sure you write them down and note them and bring them back to class next time. I'll be happy to answer them at that time.